Hi everyone, Mrs. Windmaker here. Today we're going to be talking about the equations of circles because we've been doing a lot of theorems about circles, but we haven't actually looked at what if the circle were on the coordinate plane? What would its equation be? Just like an equation of a line, a circle also has an equation, right? So if we start off here, just to kind of warm up to the idea of the equation, let's say that this was our circle and it was on the coordinate plane. Let's say the center was at the coordinate 3, 0, and then we had some point over here. Let's say it was like 7, -6 or something. Okay. And I asked you, what is the radius of the circle? So we know what a radius is. Obviously, a radius is the distance to any point on the circle. So if we were to connect the radius right here between these two given points, if we wanted to find that length or that distance of the radius, we would do exactly what we were doing before we were on e-learning. When we were finding a distance, we could use the distance formula. A lot of you might remember we kind of turn that into Pythagorean theorem though, right? We make ourselves a little bit of a right triangle. So this probably isn't very to scale, but let's take a look. How long would this side of our triangle be? So if we're looking at our x values, if we had 3 and 7, that would be a distance of 4 for the x difference. And then over here from 0 to -6, that height here would be 6. That would be our distance in the y direction. And then if we did a little Pythagorean theorem, 6 squared plus 4 squared would get us our radius squared. So let's take a look. We have 6 squared, so 36 plus 16 equaling our radius squared. So we're at 52 is our radius squared, and we could take the square root and we would have our radius. Now, believe it or not, what we just did here is actually kind of similar to how we're going to come up with the equation of the circle. It's very much based on the Pythagorean theorem because obviously that's our favorite theorem ever. We use it all the time in geometry. So let's say that I generalize this a little bit more. Same circle, we're going to pretend it's on the coordinate plane, but for our center, instead of having an actual coordinate with numbers, for now we're going to call it h comma k, where h is an x value and k is a y value. When we're talking about the equation of the circle for the center, we use hk, just as a special name of it. And then over here, the radius really could have been drawn anywhere, right? But for our purposes, we've got it right here. We're going to call this point x comma y. Any point along the edge of the circle, we'll call h or xy. Center is hk. So if we do that same thing, turn this into a right triangle. Before we were looking at what's the difference between 0 and 3. Now we're looking at what's the difference between h and x. For our purposes, we can just subtract them, right? So this side would be x minus h. And then over here, we can do the same idea. Now, ideally, it's not going to really matter which one we go first, but for the equation, we'll put y minus k right here. That's how you'll see it in the equation of the circle. And now if we do Pythagorean theorem, we could say one of our legs, x minus h, squared, plus our other leg, y minus k, squared, equals the radius squared. And believe it or not, that is what we call standard form of the equation of a circle. Okay, so how an equation of a circle is actually going to look though, you're going to have an x, and that's not going to change. You're not going to put a number right here. But if our center of our circle, we'll do one more edit to this. Let's just make up a point. Let's say the center of our circle was at 5, -3 or something. Okay, so we're going to have x minus the x value of the center. So we'll put the 5 right here. And then the y is also going to stay, but we're going to say minus the y value of the center. So minus the -3 would actually make that appear as a +3 in our equation. Okay, and then we'd have to figure out what the radius of the circle was. Let's say that we were given that this particular problem had a radius of 4. Okay, so we could put the 4 right in here as our radius, but that's really not simplified. So the only thing that we're going to have to do to simplify our final answer is we're actually going to square the 4. So if we square the 4 and write 16 instead, This is the equation of a circle that has a center at +5, -3, kind of opposite of what it looks like in the equation, and a radius, which is really the square root of this, because remember the equation ended with r squared because of the Pythagorean theorem. It's like our c squared in our Pythagorean theorem. So that's it. That's all an equation of a circle is. We're at 5 minutes, but maybe we could just do one more quick example. Pound that in before you guys go and try some practice. So if this is our circle, and let's say the center was at -8, 0, and our radius was a length of √17. Okay, so if we want to write the equation of this circle, we're going to say x minus the x value of your center. So minus the negative will look like plus in our equation. We're going to square that just like the Pythagorean theorem looked like. And then we're going to do y minus the y value. Well, since we're not subtracting anything, we're just subtracting 0. You don't even have to write the -0. We could just leave that as a y squared. And equals our radius squared. So the only thing that we have to do for our final answer is simplify that radius squared. The square root of 17 squared, well, our square root and squared sign will leave us with just a plain 17, and that would be our answer for the equation of a circle. So there's a few more things we can do with this, but I think that's a good start to get you going. Go ahead and try those practice problems, and if you're confused at all, stop by office hours tomorrow. All right, talk to you guys soon.